Welcome to the Center for Information Technology Policy's lunch seminar. My name is Stati Chattopadhyay, and I'm the Associate Director for the Center for Information Technology Policy. I would like to welcome all of you to another lunch seminar at CITP. Our talk today is titled Beyond Algorithmic Bias, an integration of Google search by image algorithm. It is also our pleasure to introduce today's speaker, CITP's very own Orestis Papakyriakopoulos, who is a postdoc here at CITP. He has a background in analyzing politics, biases, and discrimination on new and old media through the application of data-intensive algorithms. And he studies the ethics and political impact of the use of data-intensive algorithms. Here at CITP, Orestis researches how online platforms employ AI algorithms to influence politics and society. He works on a large range of topics, including AI ethics and its impact on society. Orestis has a master's degree in civil engineering from the National Technical University of Athens and a master's degree in philosophy of science and technology from the Technical University of Munich, where he also received his PhD in computer science. In 2019-2020, he was a visiting scholar at MIT Center for Civic Media. Joining Orestis is his co-author, Arwa Mboya, who will also participate in our Q&A section of this talk. Arwa is a researcher and designer from Kenya who's interested in storytelling at the intersection of art, technology, and social change. She studied at Yale University and the MIT Media Lab. Before I hand it over to Orestis, I would like to briefly go over our format today. Orestis will present for about 45 minutes, and at during his presentation, you're welcome to use the Q&A box below at this webinar to type your questions. Orestis and Arwa will both take questions only after the 45-minute presentation. At that point, you can also raise your hand if you would like to ask the question yourself, and we will unmute you so that you can ask your question at that point. So let's get started with Orestis' presentation. I'm excited to now hand it over to Orestis. Orestis, thank you for being here.
Thanks a lot, Tithi, for having me here. I'm really happy to be presenting this project. Let me share my screen. I hope it works now. Thanks again for being here. I'm really excited to present this project that Arwa and I performed, which is an investigation of a component of the Google search engine. And the aim of the project was not also to investigate if the algorithm treats unfairly individuals or social groups, but to reflect what does it socially mean, what are the social reasons why this is happening, as well as to reflect to obstacles and issues in performing an algorithmic bias study. So a bit background about algorithmic bias and about computer vision bias specifically, because the algorithm is an algorithm that takes an image as input and returns a label and some other results to an individual. So algorithmic bias studies have already shown that a variety of issues exist in commercial and non-commercial algorithmic implementations. The seminal work of Puolamwini and Gebru showed that, for example, commercial systems classify non-white individuals and female genders with lower accuracy than male and white individuals. In a study, for example, Wang et al. Show that when algorithms cannot recognize clearly if it is a male or female person in the image, they will assign a male label with a much higher probability. And similarly, for example, Swemmer et al. Showed that when putting images of US politicians in algorithmic systems, the algorithms will provide much more appearance-related labels for female politicians, as well as the algorithm will recognize them with much lower probability. And when we talk specifically about the Google search engine, there is a long history of biases that have emerged. For example, one of the first studies that mentioned such biases in K et al., they showed that actually when you search for a profession in the Google search engine, you will get results that correlate to the gender occupation of the professions in the actual society, in this way reinforcing existing social structures. And similarly, Noble, the author of Weapons of Mass Destruction, not only claimed that these biases are directly visible, but also in many cases they are latent, but they are still there. For example, to show this example that when searching for unprofessional hairstyles for work, you would get black individual images, while when searching professional hairstyles for work, you would get white individual images. So it is clear that the Google search engine in general carries biases that are more or less visible. Now, the Google search by image algorithm is an algorithm that you can feed an image or drag and drop it. For example, here I am inserting a sunflower image, and the algorithm returns a label, farmer planted 2 million sunflowers, some similar images, and also some links that might be associated to this image. We wanted to investigate this algorithm because although it is on the search engine, it is less used, and it's not it's not directly visible that you can use it to get results. And if to the question, does this algorithm contain biases? The answer is yes. So when we ran simple queries, we immediately got some biases. For example, when inserting this image of a Tuareg, of a woman of the Tuareg ethnic group in West Africa, the label was most Black women in the world. And we also put images of Arwa and me in the algorithm. And at one image of Arwa, the algorithm returned the word Afro. But the image that was associated with an Afro was a white man with a carnival wig. So it is clear that the algorithm contains strong biases. But for us, it was important to structure these biases in firm knowledge that can be useful and constructive. So for that, we draw from theoretical work and previous studies. And one of the main studies we drew from was a paper of Bourdieu et al., which was actually focused on NLP algorithms, but in my opinion, it can be applied, what they state can be applied in general in algorithmic bias studies. So they claimed that algorithmic bias studies are often vague, inconsistent, and lacking normative reasoning. What does it mean? Doing an algorithmic bias study, automatically you are normative. What does this mean? It means that you say that something in the society is not okay. But how this is operationalized sometimes is inadequate. For example, a lot of studies evaluate how mathematical representations of words, called word embeddings, carry biases. And for example, in this study here, the author showed that flowers are going to be more associated to more pleasant words than insects, and similarly, science-related concepts will be associated more to male individuals, while art-related concepts more to female individuals. Now, this shows that there is an issue there, but studies a lot of times fail to associate these issues to socio-political structures. What does this mean? Why is it important that the algorithm associates male individuals with science and female with arts? Why does it happen? It's not enough to say that this is due to the data, the input data? What are the historical conditions in the society that lead to this effect? And should we change it, and why? For example, if we want to find concrete harms on models that they were trained on word embeddings or on another algorithmic implementation, it is important to say what this harms is. For example, in which case will it be problematic if an algorithm we find flowers more pleasant than insects, and why? So based on this work, we decided to combine social theories together with the computational analysis in order to make more sense of the results the results we got. Why? Because if we draw from appropriate social theories, we can understand algorithmic inferences better. We can understand why something appeared in a data set, what does it mean for an individual if they are affected by an algorithm, and so on. We can also understand better the world. The algorithm is not an isolated part that we treat separately. It belongs to our society, and sometimes we split the two. In this way, we remove the barrier between algorithm and the society, and we can see what the algorithm does, associate it to the creators of the algorithm, and associate it to the rest of the society. And of course, because we use a data-intensive approach, the fact that we can get such a high volume of results can be valuable for the social theory application when interpreting the results. So in our study, we tried to do three concrete things. The first one is to combine social theory and computation, as already said, to write down and outline scientific and ethical issues while doing the algorithmic bias studies, as you will see further, and also since we do an algorithmic bias study, we take a normative stance to do it in a way that we can provide more awareness on the issue. The first theory we adopted came from the French sociologist Bourdieu. I cannot speak French, I don't know if I said the accent correctly, and we used two concepts of his theories, cultural reproduction and symbolic violence, and I'm going to describe them now. So you can look upright on the graph. Imagine that the subject exists in the society, a kid. The cultural values that the kid will learn and will have in their life in the society, with cultural values being its behavior, the social norms that they will have, the beliefs, the symbols they will use, the language, and so on, is a result of two main things, said Bourdieu, education and family. So these two shape the cultural universe of individual. And this cultural universe is mediated further by the subjects in the society. And Bourdieu called symbolic violence when this cultural reproduction takes place unconsciously. So a lot of times we learn things at school and without thinking about them, we use them and we repeat them also in our everyday life. And in this way, we replicate existing sociopolitical structures that exist in the society. And what we claim is that actually the algorithm is no different. If we put the algorithm, the epicenter, it is trained, shaped in a specific culture, which is constituted by the design values, what the decisions of the engineers and algorithm owners, and also the input data that the algorithm takes. Furthermore, also which input data an algorithm takes is again a decision of the design values of the engineers and the algorithm owners. So any result of the algorithm now can be associated with the individuals who actually created the algorithm, assigning responsibility and not saying that an algorithm is responsible for something. It's not. Furthermore, the algorithm itself leads to social and cultural reproduction, since the decisions of the designers and the values that exist in the dataset are mediated further in the society. Based on Bourdieu's theory, we frame the first two research questions of the study. How does the algorithm see people of different races, genders, and ages? Which cultural and social structures are reproduced by the algorithm? But in order to answer these questions, we have serious obstacles. There is no way that we are not going to be biased in our analysis. What does it mean? The first problem is that when we try to use a data set to analyze the Google search by image algorithm. So we want images to show to the algorithm. Nevertheless, unbiased data sets are really difficult, almost impossible to achieve. For example, we adopted a dataset, the UTK face dataset, because it contains some metadata. It contained racial attributes, gender attributes, and age, which could be useful to later evaluate the Google algorithm. Nevertheless, these metadata were not created by surveying individuals. The individuals were not asked and they responded. The authors used other algorithms that were trained on other data to predict a person's race, gender, and age, which of course, as you understand, it's not a good practice, because you cannot assume someone's gender, you cannot assume someone's age, and you cannot assume someone's race as well, like it is it is a personal thing, and each individual should be asked. Furthermore, the racial categories they created were already problematic in a sense. So you can see the categories were white, black, Asian, Indian, and other, which Indian is actually an adjective representing individuals from a country and not even a race. Still, despite this poor representation of social groups and biases, we use this dataset for two reasons. First, we believe that still we can find and understand a lot of things about the Google search by image algorithm. Second, we wanted to underline this ethical and scientific problem when conducting studies like that. The second problem and obstacle in our study is us. We are always biased. We are practically unable to assess what is harmful and important to social groups we don't belong to. For example, I can tell you what is harmful and discriminatory against a Greek white male. And another can say about their social group. And during the study, I also learned a lot. For example, I learned the political importance of black hair, which I would not be able to know if I did not do the study with Arwa. So there is a specific limitations because we are who we are in assessing the algorithm. The second is that what we understand as culturally and socially important when interpreting the results is again relative. And I will give you an example. In Greece, wearing black was a social norm in cases you became a widow or a widower. Until some decades ago, individuals had to wear black until they die if their partner died. And for example, this is something that was important in the Greek culture that would not exist in another culture. And thus, as an example, such elements that exist across cultures might be missed when we perform the study. An individual being in another study would look for other things in the results. And these are important limitations to take into consideration. And we don't believe that these obstacles are detrimental for the study. In contrary, we believe that by recognizing them, we can win, we can learn, we can extract knowledge. And we draw from that from Donna Haraway's seminal work that she stated that every knowledge is situated knowledge. What did she mean with that? It means that when we try as researchers to generate knowledge, to observe something, describe it, and interpret it, we are bound to the realities we come from. and these realities are not only our experiences, but also the social position that the society has put us and placed us already. Our gender, race, class, and any other thing. But by saying that, hey, I am a white, bald male and Arwa is a black woman and we are performing XY study about that and we can have these specific limitations, we actually can contribute fruitfully to the scientific discourse. Why? First, we are accountable for what we say, and furthermore, we allow researchers that come from different perspectives and positions to interpret our results better, and in this way we can result to more intersubjective knowledge. And the third theoretic framework we drew from was studying up. This was the studying up as a concept comes from this from Laura Nader, an anthropologist, who stated that it's time to change how we perform our studies. Instead of studying always the minorities and what their harms are associated to the minorities or how the minorities behave, we should study up. We should analyze the upper end of the social power structure when investigating a cultural system. So Barabas et al. Made a call to reorient the study of algorithmic fairness upwards. And what does it mean? For example, what they did is they said, okay, we are assessing a judicial risk assessment tool. Instead of putting people who were in jail and see how the algorithm assesses them, we are going to put judges as objects of the algorithm to see how the algorithm labels the judges. In this way, not only we learn about another social group in the society, but we also democratize science because we place the social asymmetry in the epicenter of our study. And in this way, we generated our third research question, which is what happens when individuals on the top of the techno-hierarchical ladder become the objects of the algorithm? What happens when we put owners of tech companies and C-suites members as images in the algorithm? How does the algorithm label them? Now I'm going to give a brief overview of the studies we used. So we created a study design where we created a crawler that was sending images, prompts to the Google webpage, and we were collecting only the labels that the algorithm was returning. We focused only in that part of the algorithm because we wanted to exhaust and analyze it in detail. So we showed 42,000 images of the previously mentioned dataset, which contained either portraits or captions of individual faces. In this way, we wanted to give minimal information to the algorithm and see how the algorithm will respond. Furthermore, we used the crawler with a German IP, although the website was in English. So we wanted to see if by changing our location, the algorithm will personalize their results to us. We used language detection models to classify the different languages in which the labels of the algorithm were returned. And we used named entity recognition in order to understand syntactic and other features that in the labels of the algorithm. And you can see here an example label of the algorithm when we fed this picture in it, which returned famous African American women. Furthermore, we did not we did simple word counts by each social group, that's race, ethnic group, and gender, in order to see which were the most common labels associated to each group. Then, based on the metadata we had with the initial data set, we compared gender-related labels of the Google search by image algorithm and see how much the two classifications agreed with each other. We used entropy-based measures to measure how diverse labels were for each social group. in number of unique words and so on. And also we generated a list of 40 adjectives that were included in 6 different categories that were related to external features, appearance, social status, and so on, that I will present later. And we built logistic regression models to see which groups were statistically associated to this label. And in order to start the app, we created a list of 18 C-suits, individuals and platform owners, and we collected 10 images for each individual, and we fed them to the algorithm. But we did not collect images from the Google search engine in order to feed it to the algorithm, because then the algorithm directly recognized the name of the individuals, or in 90% of the cases. In contrary, what we did is we saw videos and we took screenshots of the individuals, captions, and we fed the captions in the model. In this way, we stripped the privilege out of these individuals, and in order for the algorithm to treat them as normal people and label them accordingly. And now I'm going to present the results of the socio-computational interrogation. So on the top, you can see some labels that the algorithm returned. For example, old lady on beach, Italian actors over 50, happy African with laptop. Simply by doing descriptive statistics in the results, we immediately saw that basic elements of the culture of the algorithm was race, gender, age, and appearance. So these were recognized all the way, but the most common return label was celebrities. So because the initial dataset was created by images existing in the internet, many celebrities were in it, and famous people. And in 13% of the cases, the algorithm returned the name of the individuals that were on the images. Furthermore, 7% of the labels included a racial or ethnic group related term, 4% an age related term, and 2% the location related term. This is interesting because although on the initial dataset we wanted metadata related to race, age, and gender, the algorithm itself also perceived the world in these categories. Furthermore, 45% of the labels included a noun, 15% an adjective, and a bit more than 5% a verb. And in most cases, these nouns and adjectives were related to a person's appearance. Further results show similar elements in algorithms culture. So 15% of the labels were gender related. Interestingly, 28% of the labels included non-binary references, while 44 labels included the sexual orientation of an individual. So we see that gender and sexuality are cultural and appearance-related features for an algorithm, which is, of course, someone can be critical to that. Furthermore, the language, the algorithm associated language to the images of the people. So although most of the labels were in English language, from 70 to 90% by depending social group, the algorithm adapted the language they return labels based on an individual. For example, on average, the algorithm returned 1% of the images in Hindu language, but when a person was classified as Indian in the initial dataset, the Google search by image returned 6% of their labels in Hindu. Similarly, for people classified as Asian, this probability exceeded the 8%. So language was also an element of algorithms culture and was associated to images, to person's appearance. Now, when we looked at the labels by gender and social group, it became much more interesting. So, for example, we can see on the top left some top labels associated to each group. And we can see that in almost all cases, the algorithm returned the label girl to female individuals, which in specific contexts, it can be derogatory. Furthermore, for Asian and other social groups, the images were misclassified as boy a lot of times. And similarly, when we look also at the male labels, we can see also some biases. For example, Asian and other men were also associated to the label girl. Black individuals were associated to the stereotype of the player. And we can also see that all non-white individuals were labeled with the term human, which is the most trivial term someone can assign to a picture of a person. Then we saw that when comparing the gender-related labels of the Google search by image algorithm and the metadata of our initial dataset, the white male individuals were the least misclassified. Furthermore, the labels were the most diverse for white male individuals. So we see a systematic stereotypization and unfair representation of social groups. When we interpreted the logistic regression results, we came to similar conclusions. So you can see here the categories of adjectives we tested in our logistic regression models that were related to attractiveness, character, sentiment, status, feature, and size. And we found that white males were associated to the most positive character trait, with the most positive sentiment, and also with the higher social status adjectives. In contrary, females and non-white individuals were associated with good and bad attractiveness labels, with size-related labels, and in general with external appearance labels. That could have been, for example, average, or human, or dark, or light. Going one step further, there was a persistent sexualization and exotization of non-white females. So there were a lot of labels: the sexiest woman in A place, the hottest woman in B place, and so on. Furthermore, the human label to non-white males was appearing over proportionally. So this simplification is generally associated in theories with stereotypes, because stereotypes are based on simplification. So we see a structure of white patriarchy that the algorithm reproduced in its culture. And not only that, in this white male patriarchy existed what it is called hierarchy of masculinity, with on the top being the white man. And to do this results even more graspable, there was a repetitive social othering of social groups. If you were a white man, everything was good, or in most cases. If you were a white woman, it was the most probable it would be that you would be assigned the term blonde. If you were a non-white woman, you would be hot or sexy. And if you were a non-white man, you would be human. So this theme of hot and human was really persistent in the results we got. So there was a constant social othering of social groups. Now, this cultural reproduction of white patriarchy, it was interesting to see if we will encounter it also when we studied up. So first, I'm going to present the results for the male individuals in the tech industry, and then the female ones, and we will compare them. So you can see the names and the picture of each individual on the image, and when their name, and there is a bubble on each image. So each bubble has a specific color and a specific number. The color corresponds to a specific label that you see in the middle, and the number corresponds to how many times this label appeared. So remember that we inserted 10 images for each individual in the model. Now, because the labels were there were too many labels for the male individuals, we labeled a lot of them that appeared only once with the gray color. So you can see that the most appearing label was gentleman, but usually the algorithm recognized the individuals, although we tried to strip them of their privilege. Then we had a lot of diverse labels that were related to values or positive characteristics such as public speaking, business person, fun, and so on. But also we can see some bias incidents such as singing, or I think Eric Schmidt was labeled one time as a police officer. But in general, the labels were really diverse. Now comparing to the labels assigned to females, here we see that labels are much less diverse. Not only that, only one individual was recognized by the algorithm, Amy Hood. Furthermore, there were the most common labels were two, girl and blonde. So, and last but not least, also Marissa Mayer was associated with a sexual label. So you can see when you compare the male and the female labels that the male labels were much more diverse, much more positive, the individual were much more recognized, and we can see that also when we studied up the exact same white patriarchal values were replicated by the algorithm and projected on the individuals. So, in our interrogation, we found that the Western white patriarchy was a core element of the algorithm's culture. There was a clear hierarchical invisibility of social groups and the systematic otherness of individuals belonging to specific groups. And this reproduction also has a further implication. I don't believe that if the designers of the models knew that the model behaved like that, they wouldn't have removed the biases. So I believe that they did not have adequate design values and structures to think about these issues and take them into consideration and mitigate them. Furthermore, the biases in this socio-political reproduction we located comes with real-world harms, both allocational and representational. Individuals who face stereotypes or unfair or problematic labels when they use the Google search engine will be impacted negatively in psychological terms. Furthermore, unconsciously, this constant social reproduction leads to what Gillespie called calculated publics. When you use a search engine as Google all the time, you will also learn to perceive yourself in the way that the search engine perceives you. And finally, we believe we went one step further and raised further awareness by studying up and provoking the individuals high in the social ladder by showing how the algorithm is presenting them. And the study comes with specific scientific and design implications. The first one, the scientific ones, are related to the data sets and the models we used and the decisions we had to make. We know that our study also carried biases that unfavored specific social groups. And in the future, it would be ideal to create data sets, for example, that present identity as constructed, are self-disclosed by the individuals, and also fluid, since given the constructed nature of gender and race. Furthermore, when we use pre-trained models, we had the issue that not only many times they were not available in languages they were not English, but because remember, we did not only get English labels from the model, but also their accuracy was lower in other languages. And from a design perspective, model designers should create frameworks that mitigate these such programmatic representations of social groups at the end product. And for that, they should think and develop ethical guidelines and practical solutions to achieve it. Thank you very much for being here, and I'm looking forward to your questions.
Thank you, Orestis. That was a fascinating presentation. If you want to ask Orestis and Arwa a question, please sort of type your question in the Q&A box. And if you want to ask the question yourself, you're also free to raise your hand. While we sort of wait for questions, I can see a comment in the Q&A box, but it's not a question. So I'm just going to ask Orestis a question myself while we wait for other questions. In this study, Orestis, you chose to sort of go beyond the use of computational tools and sort of incorporate socio-theoretical framework. Were there any significant challenges that you faced when you sort of use these socio-cultural frameworks instead of using purely computational methods?
Yes, sure. Thanks, Tithi, for the question. So I believe that prior studies also wanted to do it, but it's difficult to associate the two aspects a lot of times, not only because you need to have interdisciplinary knowledge, that a lot of times it's not there. It's really difficult if you have a restricted amount of pages to write a paper or to provide some results, to both analyze in detail the social theoretic and the computational component. And in this way, it's not possible to combine them satisfactorily a lot of times.
Thanks, Orestis. I'm also going to request, before we have another question coming, but before I sort of go to that question, Arwa, if you'd like to put your camera on and answer questions, you're welcome to sort of do so as well. Matt Solgonik, our director, the director of CITP, has a question for you. We're going to unmute Matt right now so that he can ask the question himself.
Hello, can you hear me?
Yeah, we can hear you, Matt.
Great. Thank you both for this really interesting research. I have two questions. The first is, I was wondering what the search engine claims it's doing. Like, what are these labels supposed to represent? Like, what are they trying to do? And if you could compare what they've done to what they say they're trying to do. And then the second question is about the harm. So I thought it was great how you tried to situate this algorithm inside of the social environment. And at the end, you talked about harms that you think are happening, but those didn't seem to be measured in the same careful way as the algorithmic behavior was measured. So I'm wondering if you've thought more about how you could measure the harms and kind of quantify their magnitude in an absolute sense, and then potentially relative to the harms that come from other forms of discrimination that happen in society. Thank you.
Shall I go, Arwa, or do you want to go?
I'll answer the first one. You can answer the second one.
Cool.
Yeah. Okay. Yeah. So Google fact check. Google. The labels are supposed to explain what an image is, and provide more information about what it is. And so now, as recently as like 6 months or so ago, Google introduced a fact check option into the image algorithm function, so that if like you go online and see a picture of a horse, but it's actually a whale, you can fact check it and then enter what that image is. So I think features like that tell us that Google wants to use the labels as a way to correctly identify what is in a picture. And I think that serves both the population, but also their algorithm itself. So yeah, I think that answers your first question, Orestis. I don't know if you want to take the second.
Yeah, sure. So I believe that the harms can be, our study did not focus in quantifying the harms, but I think it could be done by a user study where users insert images and react to what the algorithm shows to them or which labels assigned to them, and then they can we could really quantify how it influences psychologically an individual.
Thank you both.
Thanks, Matt. The next question is from Omar Nayak. I'm going to actually ask Omar to sort of he has a series of comments as well. So I'm going to sort of ask Omar to ask the question himself. We'll unmute you, Omar, so that you can ask your question yourself. Omar, you're on. I think Omar's still muted. Omar, you're still muted. Can we unmute Omar? All right, we'll come back to. We'll unmute Omar and we'll go to a little later, we'll go to another question that we have. This is from Elizabeth. She sort of asked, in operationalizing cultural reproduction, can you talk about how algorithms reproduce the choices of their developers versus how they might be reproducing the choices that went into the machine learning data sets? How do we understand cultural reproduction as expressed by developers versus model versus data sets?
Thanks for the question, Elizabeth. Shall I go, Arwa? Okay, thanks. So that's a great question. So ideally, the correct practice to understand what the creators of the algorithm think and what they did is to interview them and talk with them and see how they made decision, and that's not possible. But still, if you have experience in creating these models, someone can understand that, for example, the choices they made result to these biases, because usually what happens, I don't know in this case, but in other cases, for example, they want a model that interacts very well with their users. So they take the data that users have generated, that they carry all this bias and reproduce the specific culture and put them as input as a model. In the model, in this way, this culture is being reproduced. So it's not so much about, furthermore, of course, if you have more diverse designers or individuals who face specific issues, when these people are going to create models, they are going to be much more conscious to check for possible issues and make models that do not include them.
Thanks, Orestis. We're going to try to unmute Omar again. All right. Since we're unable to unmute Omar, I'm just sort of going to ask another question. Orestis and Arwa, whoever wants to answer this, can you tell us a little bit about the benefits of studying up, and if you encountered any ethical challenges while sort of studying up?
Okay, I can answer some of this. I think we found it really exciting and challenging to be able to question how algorithms treat the people that sort of arbitrate them. And like Orestis said, our biggest struggle was that we couldn't go onto Google onto Google to search up their faces because they had already been labeled, and so had to by sort of circumnavigate the system for us to be able to use these images. I think something that was hard for us that Orestis didn't bring up was in general, like coming up with a list of highly recognizable women in tech in the first place was quite difficult. There were some obvious names like Sheryl Sandberg from Facebook, but in general, it was quite difficult to figure out, who are the women that we should be using in this space. So even just starting in that practice was a challenge for us. And I was really keen to make sure that we kept it balanced. So it wasn't all that surprising that there was so much richer data when it came to the men in power than there was when it came to the women, because even I myself couldn't really think about who should make up that list as easily as I could think of for the men. I don't know if you have something to add to Orestis.
Yeah, I totally agree. And I could also add that also by studying up, for us, it was also a way, and I think it is a way to bring the problem closer to the decision makers, those who have the power to change, because now they are the object and they can feel what it means that an algorithm treats you unfairly.
Thank you both. We have another question from Miguel. He says, I was not aware of meta studies like the one from Packard 2018 you mentioned. That was very interesting. My question is how you both anticipate the field might incorporate these insights from sociology, philosophy to design computational probabilistic methods for generating synthetic metadata or observations or other topics, with the goal of balancing training data or improving our ability to empirically understand bias. Do either of you want to take it?
Shall I go, or do you want? I believe that there are efforts to include social science more and more, and in the algorithmic fairness community, researchers try to do it more and combine computational tools with social theories, and more programs are getting interdisciplinary. Even in big conferences such as NOIRIPS, they take into consideration now more and more the ethical component in performing studies. And yeah, I believe it is changing how the studies are performed, and that's also very good.
All right. Thanks, Orestis. I think we have another, so I'm just going to go over, since we could not unmute Omar, I'm going to just quickly he has a comment here. Maybe either of you can reflect on his comment. Omar says he's done the same kind of research, but the difference between your results and his research were the same, but the path of the result was different. The basis in Google search and image results were not based on AI. In fact, the results came from the different kinds of users themselves who feed the data to manipulate the codes of their own favor. One example is, one of the famous cases was about Michelle Obama. And another example was, if you search search for Black man, you can see the image of Donald Trump. So if you just wanted to reflect on his research, and you can just contact him. He's also provided his contact information. I just wanted to share that with both of you.
Cool, thanks. That's interesting, and I agree with him. So indeed, the labels that the algorithm returned, they were a lot of times queries that users have run. And this is what I said, that probably the algorithm learns from what users want to see and what they are searching for, but still this does not reduce the issues that the algorithm carries.
All right, I think we have another question. No, I don't think we have another question. It was, I think we're done with all our questions. If there are other questions, feel free to raise your hand. I'm just going to check one more time, but otherwise, thank you, Orestis and Arwa, for both being here. It was a fascinating talk, and we hope to see all of you next time at our CITP lunch seminar.
Thank you very much, Stacey, for having us.